Hey, what's going on, guys? My name is Zero Davila. Welcome back to Save Our System IT. Today we'll continue with part 9 of our BusyBox series. The host ID program outputs a number, the host identification number or host ID, which identifies the current system. This unique number is based on the machine's IPv4 network address and is represented in hexadecimal. Host name is used to display the system's DNS name and to display or set its host name or NIS, Network Information Services domain name. When called without any arguments, hostname will display the name of the system as returned by the getHostname function. When called with one argument or with the $-file option, hostname will set the system's hostname using the setHostname function. Only the superuser can set the hostname. The hostname is usually set once at the system startup in the script /etc/init.d/hostname.sh, normally by reading the contents of a file which contains the hostname, like /etc/hostname. HTTPD is the Apache Hypertext Transfer Protocol HTTP server program. It's designed to be run as a standalone daemon process, and when it's used like this, it will create a pool of child processes or threads to handle requests. Its main application is to set up a small web page on the local machine, and it's one of my favorite parts of the BusyBox binary. The clock that is managed by the Linux kernel is not the same as a hardware clock. Hardware clock runs even when you shut down your system. It's also called the BIOS clock. You can change the date and time of the hardware clock from the BIOS. However, when the system is up and running, you can still view and set the date and time of this BIOS clock using the Linux hwclock command. hwclock is a tool for accessing the hardware clock. You can specify the current time, set the hardware clock to a specified time, set the hardware clock to the system time, and set the system time from the hardware clock. You can also run hwclock periodically to insert or remove time from the hardware clock to compensate for systematic drift, where the clock consistently gains or loses time at a certain rate if left to run. The ID command prints real and effective user and group IDs. So it prints the user and group information for a specified username or when username is omitted for the current user. To log into a computer, we need the username. The username is an identity to be recognized by the machine. Based on it, the machine will apply a set of rules to the user that logs in with that username. Some applications may need the user ID and group ID to be run, so ID makes it easier to find the UID and GUID of a user without searching it inside the /etc/group file. Ifconfig is used to configure or view the configuration of a network interface. Ifconfig stands for Interface Configuration. It's used to view and change the configuration of a network interface on your system. Running the ifconfig command with no arguments will display information about all network interfaces currently in operation. ETH0, LO, and WLAN0 are the names of the active network interfaces on the system. ETH0 is the first Ethernet interface. Additional Internet interfaces will be named ETH1, ETH2, and so on. This type of interface is usually an NIC connected to the network by a Category 5 cable. LO is the loopback interface, and this is a special network interface that the system uses to communicate with itself, and WLAN0 is the name of the first wireless network interface on the system. Additional wireless interfaces would be named WLAN1, WLAN2, and so on. These are the traditional naming conventions for network interfaces under Linux. Other operating systems may have different names. For instance, under many BSD operating systems, Ethernet interfaces are named EM0, EM1, and so on. Check your configuration or consult your documentation to determine the exact names of your own interfaces. When a network interface is active, it is able to send and receive data. When it's inactive, it's not able to transmit or receive data. You can use ifconfig to change the status of a network interface from inactive to active or vice versa. To enable an inactive interface, provide ifconfig with the interface name followed by the keyword up. Enabling or disabling a device requires superuser permissions, so you will either have to be logged in as root or prefix your command with sudo to run it with superuser privileges. ifconfig can be used as a command line to configure or reconfigure a network interface. This is often unnecessary, since this configuration is typically handled by a script when you boot the system. If you'd like to do so manually, you need superuser privileges. To assign a static IP address to an interface, specify the interface name and the IP address. ifconfig is used to configure the system's kernel resident network interfaces. It's used at boot time to set up interfaces as necessary, and after that it's usually only needed when debugging or when you're system tuning. If no arguments are given, ifconfig displays the status of the system's active interfaces. If a single interface argument is given, it displays the status of the given interface only. If a single -a argument is given, it displays the status of all interfaces, even those that are down or inactive. In all other cases, ifconfig configures an interface according to the options provided. Init is the parent of all processes. Its primary role is to create processes from a script stored in the file /etc/init tab. This file usually has entries which cause init to spawn GTTYs on each line that users can log in. It also controls autonomous processes required by any particular system. A run level is a software configuration of the system which allows only a selected group of processes to exist. The processes spawned by init for each of these run levels are defined in the /etc/init tab file. Init can be in one of 8 run levels, 0 through 6 and capital S or S. The run level is changed by having a privileged user run teleinit which sends appropriate signals to init, telling it which run level to change to. Run levels 0, 1 and 6 are reserved. Run level 0 is used to halt the system, run level 6 is used to reboot the system, and run level 1 is used to get the system down into a single user mode. Run level capital S is not really meant to be used directly, but more for the scripts that are executed while entering run level 1. Run level 7 through 9 are also valid, although not really documented. This is because traditional Unix variants don't use them. In case you're curious, run level capital S and S are in fact the same. Internally, they are aliases for the same run level. After init is invoked as the last step of the kernel boot sequence, it looks for the file /etc/init tab to see if there is an entry of the type init default. The init default entry determines the init run level of the system. If there is no such entry, or no /etc/init tab at all, a run level must be entered at the system console. Run level capital S or S brings the system into a single user mode and does not require an init tab file. In single user mode, the root shell is open on /dev/console. When entering single user mode, init initializes the console STTY settings to sane values. C-local mode is set. Hardware speed and handshaking are not changed. When entering a multi-user mode for the first time, init performs the boot and boot wait entries to allow file systems to be mounted before users can log in. Then, all entries matching the run level are processed. When starting a new process, init first checks whether the file /etc/init scripts exists. If it does, it uses this script to start the process. Each time a child terminates, init records the fact and the reason it died in /var/run/utmp and /var/log/wtmp, provided that these files exist. After it has spawned all the processes specified, init waits for one of its descendant processes to die for a power fail signal, or until it's signaled by teleinit to change the system's run level. When one of the above 3 conditions occurs, it re-examines the /etc/init tab file. New entries can be added to this file at any time. However, init still waits for one of the above 3 conditions to occur. To provide an instantaneous response, the teleinit Q or Q command can wake up init to re-examine the /etc/init tab file. If init is not in single user mode and receives a power fail signal, the sig power signal, it reads the file /etc/power status. It then starts a command based on the contents of these files. Capital F is for fail. When power is failing, UPS is providing the power. It executes the power wait and power fail entries. Capital O is for OK. The power has been restored, executes the power OK wait entries. Capital L is for low. The power is failing and the UPS has a low battery, executes the power fail now entries. If /etc/power status doesn't exist or contains anything else than the letters F, O, or L, capital letters, init will behave as if it has read the letter capital F. Usage of sig power and /etc/power status is discouraged. Someone wanting to interact with init should use the /dev/initctl control channel. More information about this is available by viewing the source code of the sysv init package. When init is requested to change the run level, it sends the warning signal sigterm to all processes that are undefined in the new run level. It then waits 5 seconds before forcibly terminating these processes via the sigkill signal. Note that init assumes that all these processes and their descendants remain in the same process group which init originally created for them. If any process changes its process group affiliation, it will not receive these signals. Such processes need to be terminated separately. Insert module installs the loadable module in the running kernel. Insert module tries to link a module into the running kernel by resolving all symbols from the kernel's exported symbol table. If the module file name is given without directories or extensions, insert module will search for the module in some common default directories. The environment variable mod path can be used to override this default. If a module configuration file such as /etc/modules.conf exists, it will override the path defined in mod path. The environment variable module conf can also be used to select a different configuration file from the default /etc/modules.conf or /etc/conf.modules, which is the deprecated format. This environment variable will overwrite all definitions above. When the environment variable uname machine is set, modutils will use its value instead of the machine's field from the uname system call. This is mainly of use when you are compiling 64-bit modules in 32-bit user space or vice versa to set the uname machine to the type of the modules. Current modutils does not support full cross-build mode for modules. It's limited to choosing between 32 and 64-bit versions of the host architecture. And that's about it for today. Don't forget to like, share and subscribe. Any questions you might have are to be left down in the comment section or on our website www.sosit.co. Again, that's www.sosit.co. Thanks for watching and have a nice day.